Okay. So today we are talking about population. Well, we're talking about density. We're talking about density. We're going to start off with population density, and then we're going to talk about density of an object. Okay. Any of you guys in physics or chemistry? Okay. So density, you talk about density. What about any of you in any kind of like that global history, whatever? Or has anyone talked about population density in any of your history classes? Yeah. Okay. Well, today we're going to figure it out. So the formula for density equals population divided by area. I will tell you right now that I know that you guys use these little triangle things in science classes. I hate them. My brain does not work like that. So density equals population divided by area. I have a math brain, right? So if I wanted to know how to find that area given this, like if I wanted to solve this equation for A, let's do that really fast. I'm going to show the work for that. Well, if I wanted to solve this equation for A, I would have to multiply both sides by A. You can just watch. And then I would get A times D equals P. And then I would have to divide both sides by D. So A equals P divided by D. We've done this before. Where if you want to solve for the number that's in the denominator, you just trade spaces. Like we did this whole little flip-flop. We've done things like this before. So hopefully that's not super hard. What if I wanted to solve for P? Well, if I wanted to get P all by itself, the population, I would multiply both sides by A, equals the density times the area. So those are the three formulas that you use for population, density, and area. Okay? Does that make sense? So now we're going to do that same exact thing, although I'm going to hide up this little triangle. So now we're going to talk about density of an object is the mass divided by the volume. So that means that the volume equals the mass divided by the density. Or if I wanted to solve for the mass, I could take the density times the volume. So no math involved there, I just solved it up. Does that make sense? Are we good with that? Okay, so we're going to do some practice problems. The density of an American white oak tree is 752 kilograms per cubic meter. So the density equals 752 kilograms per cubic meter. If the trunk has a circumference, if it has a circumference of 4.5 meters and a height of 8, what is the number of kilograms? Meaning, what is the density? Or what is the volume? No, sorry. What is the mass? This is what's asking. What is the mass? Question mark. What do we have to find out from this information about our tree trunk? Yeah. We have to use that information about the tree to calculate the volume. So our tree trunk is a cylinder. And I know that the volume of a cylinder is pi r squared h. Well, I don't know the radius of my cylinder. I only know the circumference. Let's draw a little sketch off to the side. I'm going to do a little picture. So here's like my tree trunk, right? So I know that it's 8 meters, 8 meters tall. I need to know this measure. And right now, the only thing I have is the all the way around measure. Well, circumference is pi times diameter, but circumference is also 2 pi times the radius. So if I know that my circumference equals 2 pi times my radius, and I know that the actual circumference is 4.5, so 4.5 equals 2 pi times my radius, how can I figure out what the radius is? Get r by itself? How am I going to get r all by itself? Yeah, divide both sides by 2 pi. So what is 4.5 divided by 2 pi? What? So here's how we have to do that. We have to use parentheses. So take 4.5. 4.5 in your calculator. Everybody pick up a calculator. 4.5. Check your bucket. 4.5 divided by parenthesis 2 times pi, close your parentheses. 0.716. Huh? Pi is right by the over here. Yeah. Sure, caret button. So the radius is 0.716. So now I'm going to slide back over and I'm going to find the volume of my cylinder. So the volume of my cylinder is pi times my radius, which is 0.716 squared, times my height, which is 8. So what do I get for my volume? Calculate that up. Pi times 0.716 squared times 8. 12.884. Okay, I think that we've done some rounding boo-boos maybe, but that's okay. We're gonna roll with it and see how close we get. Okay, so if I want to find the mass, I know that the mass equals the density times the volume. So the mass equals 752 kilograms per cubic meter times 12.884 meters cubed. I'm going to put this over 1 just so you can see what happens, because kids always struggle with the units. My mass is in kilograms, and the reason that happens is because you see that I have meters cubed on the top and meters cubed on the bottom. That's why my mass is just in kilograms. So my mass equals, what is 752 times 12.884? 9,688. So we did some rounding crazy, but that's okay. So which one is it really closest to? Yeah, 9,694. And this is actually kilograms. Kilograms. Okay. Let's look at our next one. A snow cone consists of a paper cone completely filled with shaved ice, topped with a hemisphere of shaved ice. The inside diameter of both the cone and the hemisphere is 8.3. So the diameter equals 8.3 centimeters. That means that the radius equals what? If the diameter is 8.3, what is the radius? How are we going to figure that out? Divide by 2. The radius is 4.15 centimeters. Okay. The height of the cone is 10.2 centimeters. Okay, so I'm going to do a little bit of drawing right here. I know that this measurement is 4.15. So the volume of my cone is the area of the base, pi r squared, times the height of the cone all over 3. So that equals pi times my radius, which is 4.15, squared, times the height of my cone, which is 10.2, all over 3. But I also have to add the volume of my hemisphere. The volume of a hemi. Well, if the volume of a sphere is 4/3 pi r cubed, then the volume of a hemisphere is 2/3 pi r cubed. Okay, so 2/3 pi times my radius, 4.15. Oh, I don't know why I wrote 1.4. I said 1.5. I'm sorry. 4.15 cubed. So we have to add these two together. So volume total equals. So what do you get? You can tell me what you get here, and then we can write down what we get here, and then we can just add them together. What'd you get? I'm not going to tell you. You just calculate what I wrote out. What is pi times 4.15 squared times 10.2 equals divided by 3? What do you get for that one? 183.961. 183.961. Units, cubic centimeters. Okay. What about the volume of the hemisphere? 2/3 pi r cubed. 2/3 times pi times 4.15 cubed. What do we get for that? I would do parenthesis, 2 divided by 3, close parenthesis, times pi, times 4.15 cubed. Go. 149.693 centimeters cubed. So what is my total volume? When I add those two items together, what is my total volume? 333 point, what'd you say, 654 or 694? 654. Thank you, sir. Centimeters cubed. Okay, so that is the volume. We have found the volume. It says the desired density of the shaved ice is 0.0697. And the cost per kilogram is 3.83. Determine the state and the cost of ice needed to make 50 snow cones. So we need to figure out our mass. So our mass equals our density times our volume. So our mass equals, well, the density is 0.0, no, it's 0. Sorry. I'm not erasing, it's just easier to color it in white. 0.697 times 333.654. So what do you get for that? What is the mass? What is it? 232.556. Okay, so this is the cost. Let me think. This is the cost per, this is given to me in grams per cubic centimeters. So the cubic centimeters cross off. So this is in grams. I need to know the cost per kilogram. So what is the difference between a gram and a kilogram? A kilogram's 1,000. So if I have 230 grams and I want to transfer that to kilograms, I have to divide by what? If I want to go from grams to kilograms, I have to divide by 1,000. That's the same thing as moving the decimal 3 places to the left. So I have 0.232556 kilograms. That's my mass. But that's just for one snow cone. And how many do I want to make? I want to make 50. So I'm going to take this and I'm going to multiply it by 50. So the mass for 50 snow cones equals what? Say it again. 11.6278, you said? Okay. So that's the mass for 50 cones. And what is the cost per kilogram? So times $3.83. And that'll tell us what it's going to cost. $44.53. How we doing? This is tough. A lot of conversions going on, right? There really are. Okay. So let's do number 3 together. The 2020 U.S. Census population and population densities are shown. So I'm just going to write the formulas really fast. So remember that the density equals the population divided by the area. And then we said, well, that just means that the area equals the population divided by the density, and area times density equals population. I want you to have the right kind of setup. So based on the table above, which list has the state's area in square miles in order? We have to list the state's areas in square miles in order from largest to smallest. So here's what we have. We're given the density and we're given the population. We have to calculate the area. We have to calculate the area of each one of these states, right? So let's do New York. So the New York area equals the population, which is 20,201,249 divided by the density, which is 429. So what do we get for New York? What is the area? Guys, you got to pick up a calculator. Here's what I want. You're taking this first number and you're dividing it by this number. So Logan, Aiden R, pick up your calculator, get your head up. Noah S, and Max. You're doing New York. Too bad. So bad you didn't volunteer. Reese. And you're doing Illinois. Reese, Kylie, Rose, and Hannah. You all have Illinois. Got it? Manuel, your whole table with Kane. Josh, Josh and Nate, you guys are doing Pennsylvania. And then the rest of you. So Trey's table, David's table, and I think that's it. Okay. ILL or IL. Okay, so I'm gonna slide over this way. So what did we get for the area and square miles of the state of New York? Any 47,000 what? Thank you. Okay. What about Illinois? I don't even care about the points. That's good. What do we get for Pennsylvania? 44,682. Perfect. And what do we get for Florida? 53,000 what? 570 blah blah blah. Got it. Okay. So we want them in square miles from largest to smallest. Which one's largest? Illinois. This one's got to come first. The 8 where? Oh, on the 57? The 53? I don't know, but 53 is smaller than 55, so I didn't worry about it. I couldn't hear what he was saying. I asked him twice, so I just put dot, dot, dot. That worked for me. Okay, which is the next one? Florida. And then what? New York. And then last is Pennsylvania. Okay. So what is my answer choice? Yeah, answer choice 1. Huh? This is like a delta math. Like this is exactly what I'm pretty sure it is. Okay. Can we do the next one? Yes. Okay. So trees that are cut down, this can be the last one that we do together. Trees that are cut down and stripped of their branches for timber are approximately cylindrical. So we're going to have a cylinder that we're going to have to calculate some volume of. So timber company specializes in a certain type of tree that has a typical diameter of 50 centimeters and a height, ooh, you got to watch for this, of 10 meters. Okay. The density is 380 kilograms per cubic meter. So density equals 380 kilograms per cubic meter. And the wood can be sold by mass at a rate of 4.75 or $4.75 per kilogram. Determine this minimum number of whole trees that must be sold to raise at least 50,000. So let's talk about this. If the diameter is 50 centimeters, what is the radius? The radius is what? 25 centimeters. Okay. What is the problem with these two items? They're different units of measure. Okay. So we are going to turn our height of 10 meters into centimeters. So 10 meters is the same thing as, well, 10 times 100 is 1,000 centimeters, right? Because there's 100 centimeters per meter. Okay, so that's our height. So our volume is the area of the base. So pi r squared. So 25 squared times my height times pi. Give me that. So 625 times 1,000 is 625 times 1,000 pi, which is about what? It's got to be way bigger than that. 196 million. Oh, okay. 1,000,000 Oh, poop on a stick. We're having technical. 1 million what? 495. Okay. So that is cubic centimeters. All right. That's in cubic centimeters. I want it to be turned into cubic meters. So let's talk about this for a second. So how many, I don't know how to ask you how to do that. How are we going to divide? We're going to divide by 1,000. Huh? Okay. But it's 100 what? It's 100 cubed. Why? Because it's volume. So 100 cubed is just what? Well, isn't it just 6 zeros? 1, 2, 3, 4, 5, 6. Isn't it that? Yeah. So what the heck? So I just take the decimal and move it over 1, 2, 3, 4, 5, 6 zeros. 6 places. 1, 2, 3, 4, 5, 6. So it's 1.96345 meters cubed. That's the volume of one tree. Okay. So we know that the density is what? So I'm going to take 1.96345 times 380 to figure out the mass of one tree. The mass of one tree. So what is the mass of one tree? 746 kilograms. Okay. Did everybody get that? Yes or no? Okay. So one tree is 746 kilograms. How much money do I make off of one tree? Well, I take 4.75 because that's the money per kilogram times 746, and that gives me the money per tree. How much money do I make per tree? $3,543, and just give me 2 decimal places. 0.50. Okay. That's what I make per tree. Okay. So the question is, how many trees must be sold to raise at least $50,000? So if I make $3,543.50 per tree, and I need at least, that's greater than or equal to $50,000, how many trees do I need to raise? Well, you just divide both. You divide 50,000 by, I'm listening. Go ahead. You can't have 0.11 of a tree, so you need to raise, yep, 15 trees. Do you guys want to do number 5? So that way you just have 1, 2, 3. We're going to do number 5, and then I'm going to probably post the answers to the others because I'm not checking it. Like, I want you to get started on your Delta math. Let's do number 5 together really fast. So a wooden cube has an edge length of 6 centimeters. So this is a cube. Has an edge length of 6 centimeters. That's a horrible looking cube. Sorry, you guys. I'm just not really feeling it today. But you get it. So the volume is 6 cubed, which is 216 centimeters cubed. That's my volume. And it has a mass of 137.8 grams. We need to determine the density to the nearest 1,000, depending on the type of wood, right? So we're going to have to figure out what type of wood we made based off of. The question is, what type of wood was used to form this cube? That's what we're trying to figure out. Well, if I want to know the density, remember that the density equals what? What formula do we write for density? Density equals what divided by what? Density equals mass divided by volume. So my density equals 137.8 divided by 216. So what do you get? .6379. So what type of tree or wood did they use? We used ash. Okay. Freeze that. I'm going to stop that.